there are functions to handle strings. So, we will see the notion of functions itself in a little detail later. So, the primary thing is string is not a basic data type. So, you have characters, integers, floating points and so on, they are all valid data types and valid basic data types, whereas the notion of a string is not a valid data type. So, there are other languages like C++, Java and so on, where string is actually part of the basic data type. Unfortunately, in C it is not. So, what it requires is you have to do something called a derived data type. So, when I said a string is an array of characters, so it is actually an aggregate data type of characters. You have several elements which are all of the same type. So, it is an aggregate type where you have more than one element of the same type. And to manipulate various things with functions, we will look at what are called string functions later. So, the notion of functions itself is not too big. So, the idea of functions is if you do something repeatedly, instead of you doing it every time, you typing the program every time, you type the program into what is called a function and you call the function once in a while. So, just like printf and scanf and so on, these are functions that you are calling, you did not write printf and scanf, right. So, we will see the notion of how to write functions, how to specify them and so on later, but as of now various operations related to strings, we will see what functions are out there that C provides. So, the typical functions on strings are finding out the length of the string. Let us say I give my name, I want to find out the length of the string. So, I need there are functions which can go and count the characters in my name and tell me the number of bytes required. Given two strings, I can ask whether the two strings are equal. What I mean by that is, so two strings are said to be equal if it has the same sequence of characters. And we can ask a question like, is something a substring of the other, right? Or I have two strings, I want to attach one string to the other and so on. So, there are functions for each one of these. These functions are available and given to you in a library called string library. To invoke functions or these methods from the string library, you need to include what is called string.h. So, just like for printf and scanf you included stdio.h, for doing various string operations we will need string.h. So, one thing we are going to do in this class initially is that we will write these functions ourselves, or we will write these programs ourselves, and then I will finally show you how to use the C library calls. So, let us say I give you a string and I want you to find out the length of the string. So, in this example we have string A, and let us say string A has hello space world followed by \0, and I want to find out the length of the string. So, what is the length of the string? I will start from location which contains h, and I have to keep checking till I find a \0. So, when I find a \0, I know that it is the end of the string, because that is how C understands strings. So, anything which is a valid sequence of characters ending with a \0 is a string. So, you go and concentrate on this segment of the program. It starts with I equals to 0. We have I which is 0 and A of I is h to begin with. So, it starts looking at that and it keeps adding. So, you can see that in the loop we are incrementing I by 1 every time I see a non-null character. So, the null character is \0. Every time I see a non-null character, I will increment I by 1. So, I starts with 0. The moment I see h, right, I is changed to 1. Now, I look at E, then E is a non-null character, I is changed to 2, I look at L and so on. So, if I keep looking at it, I will see that the length of hello world is 11. So, you have, so when I equals 11, you have \0. So, remember this is A of 0 and this location is actually A of 11. When I equals 11, this is the 12th time you are running the loop. So, I equals 11, it is a \0 character. So, what you actually have is length of these valid letters. So, the array containing all these valid letters excluding \0. So, that is the length of the string. So, hello world has 11 characters in it. So, remember there is a space in between, right. So, what we have is we have I equals to 0 and we have a loop that does it. So, do not worry about this notion of return and string length and so on, we will see that in a little while. So, this is actually a function which takes a, which is a pointer to the array, and it finds out the length and it returns the length. So, we will see this notion of passing a and returning the values and so on in a lecture on functions later. So, the basic idea is what I want you to grasp now. Let us look at another function in which I want to copy the contents of array A to B. Let us say array A is of some length and array B is of something else, and I want to copy array A to array B. And the way to do that is, so I want to go and look at size of this array. So, what I want to do is, I do not care about what is present in B. B could be actually of a size which is different from A. I also do not care about what are the contents of B already in place. I want to copy byte by byte or character by character the contents of A into contents of B. So, the H in location 0 of A should be copied to location 0 of B. For example, this L should be copied to this location, this \0 should be copied here, because I am supposed to copy the whole string, and the notion of a string is only if it is terminated by the null character. So, that is what this program segment does. So, int n1 is string length of n1. So, remember I wrote this thing called string length. If I pass hello \0 to it, it will tell me that the length of the string is 5, and we have k equals to 0, k less than n1, k plus plus. So, it will go from 0, 1, 2, 3, 4, and you will keep copying contents of location A to B. So, at the end of this, you actually have to make B of k equals \0, or you could actually change this to equal to. So, you can, so this one only copies all the valid characters. We still need to do the last one. So, we need to write B of k equals \0. This is one way to do it, or you change this condition to equal to. Either one of them will take care of copying the string including \0. So, one thing that this segment does is it ignores whatever was stored in B earlier. So, there is a subtle problem here. Let us say A had only 4 bytes. So, let us say A was all these bytes, whatever number of bytes, but B does not have enough space to copy the contents of A. This will be a problem because you are going to start looking at B, and when I start looking at B, I am going to look for \0 as a possibility, and for whatever reason, let us say I did not have any of this space. I would have copied H, E, L and L, but I did not have enough space for O and \0. This would be a disaster, because my array has lesser space than what it really needs. This is not something that this is something that you have to handle explicitly. If B has lesser space than A, what does it mean to say copy the contents of A to B? You have to be careful about that. Then let us look at this function called string concatenation, or the idea of concatenation. Let us say I have this string called world and I have a string called hello, and I want to make a single string hello world. So, that is called concatenation. What I really want is, I want to copy W to this \0, O to the next location, R to the location after that, and so on, including \0 of B to be copied here. The result I expect is HELLO, which were the contents of A, followed by the contents of B, which is WORLD, followed by \0, which says that this is the termination of A. So, I am trying to concatenate B to A, and as a result I want this. So, you can see how this is supposed to be done. So, clearly A must have space for copying B to the end of it. So, if A had lesser space than the size of B plus A included, there is a problem, right. So, in this example it is not a problem, but if B were something much larger, then concatenating B with A, you will run out of space in A. So, in this example, however, it is not a problem. Once we did the concatenation, so up till here is what you got from A, from here to here is what you got from B, and this is the extra character that you have to add to the end to ensure that when you now treat A as a string from left to right, it terminates with D. So, I am going to leave this as an exercise for you to go and write a program on your own. Finally, let us look at the notion of ordering strings, and so this is something that we do in daily life. So, if I go and pick up a dictionary, I may want to go and look at what order in which the words are occurring. So, in this slide I am looking at names of people or words. So, let us look at the word Badri and word Devendra. Right. So, clearly if I go and arrange them in dictionary, the word Badri will come before the word Devendra in the dictionary. So, I will say that word Badri coming before word Devendra, I will use the notation less than for it. So, Badri comes before Devendra is expressed as Badri less than Devendra. Let us look at this example. Janak is less than Janaki. So, Janak has only 5 characters, whereas Janaki has 6 characters. So, clearly if you go and look at dictionary, right, all the smaller words will appear before all the bigger words, right. So, in this case Janak is a smaller word than Janaki. So, even though the first 5 characters of both these are same, Janak has one less character than Janaki. So, therefore, we will say that Janak is less than Janaki. Then if you look at this example, Shiva is less than Shivendra, because if you go and look at the 5th character, it is A here, the 5th character here is E. So, clearly A will come before E in the dictionary. So, Shiva is less than Shivendra. Then Sita is less than Siva. So, SEETA is less than SITA. So, we are not looking at the size of the string alone, we are also looking at dictionary ordering, right. So, clearly SEETA will come in the dictionary before SITA. Even though the length of SITA is only 4, SEETA is of length 5. In English dictionary you would see SEETA before SITA. Then there is something peculiar about characters and languages. So, one thing that is true in machines is that all the uppercase letters in alphabetical order appear actually before all the lowercase letters. So, this is a property of how the machine treats various characters. All the uppercase letters are supposed to be lesser than all the lowercase letters, and within the uppercase letters A is less than B and so on up to Z, and within the lowercase letters A is lesser than B and so on up to Z. But capital A is actually less than lowercase a, capital Z is less than lowercase a and lowercase z and so on. Because of that, if I go and look at this example, capital B Badri is actually less than small case b Badri. So, in dictionaries you do not really make a distinction between uppercase and lowercase, but in programming strings can be different. So, lowercase could be different from uppercase. So, we have to be careful about that. As a final example, BAD is actually less than Badri with capital B, because BAD has 3 characters and BADRI has 5 characters. So, this is similar to this Janaki and Janak example. So, in fact, BAD is also less than BADRI. So, that is also true, because BAD is actually 3 characters in length, and I am sorry. So, BAD starts with a capital B, and whereas BADRI starts with lowercase b. So, this is also true. So, this is called lexicographic ordering. So, just remember that it is just like dictionary ordering with the one extra addition that lowercase letters are considered to be coming later than uppercase letters. So, we will also have to deal with blanks and other things, for example. So, let us look at this example, Bill Clinton and Bill Gates, right. So, if you go and arrange them in order, Bill Clinton should actually come before Bill Gates. So, the space itself should not matter. So, C comes before G. Therefore, if I go and look at character by character from the left side of this and character by character from the left side of this, so B and B match, I and I match, L and L match, L and L match, space and space matches, C is actually less than G. Therefore, Bill Clinton is less than Bill Gates. So, I am not making any comment over their personalities. So, in terms of a string, Bill Clinton is less than Bill Gates. Then let us say we have this example, Ram Subramanian and Ram Subramaniam. So, here up till I the characters are the same, whereas when we look at this character A and this U, A is less than U, therefore, the string Ram Subramanian is less than the string Ram Subramaniam. And finally, if we go and look at this example, Ram space Subramanian versus Rama space Avasti. So, Ram space Subramanian is supposed to be lexicographically earlier than Rama space Avasti. The reason is that if you go and look at the first three characters, right, they are matching Ram and Ram. The fourth character is a space, whereas the fourth character is A, and in storage space gets a code 32 and that comes before the code for A, which is actually 97. So, the code for lowercase a is 97. So, code for space is 32. So, since space comes before any valid letter in the sequence of characters, Ram space Subramanian is less than Rama space Avasti. So, there is a small program that I have written here which goes and looks at comparing two strings, str compare. I am assuming that there are two strings A and B. So, there is supposed to be a comma here, and let us assume that there are two integers n1 and n2. n1 is supposed to be the length of A and n2 is supposed to be the length of B. So, I want to find out if when I compare A and B, whether A is less than B or A equal to B, or whether A is greater than B. So, let us look at the examples on the right side. If A is HELLO and B is HELLO, then A is actually equal to B. So, for this example, this condition, A is actually equal to B. In this example, the second one, A equals hell and B equals hello. So, the set of characters, the first four characters are the same, but A does not have the fifth character, whereas B is a longer string. So, therefore, we claim that A is less than B. Like I said, small words will come in the dictionary before bigger words. And if A is hello and B is hell, A is actually greater than B. Then in this example, they both are of the same length, the length does not matter, but if you look at the second character, there is E here and there is U here. Therefore, in the dictionary, bell will come before bull, therefore, string A is before B. And in this example, hull is and hello, hull will come in the dictionary after hello. So, we have A greater than B. So, these are some examples. I want to be able to handle all such cases. So, let us start with the first one, A equals B. When will I have two strings to be equal? All the characters of A must be the same as the characters of B, and the length of A should be equal to the length of B also. In fact, every character including \0 should be matched from A to B. If all the characters including \0 are exactly the same, then in the order of for A and B, then A is supposed to be equal to B. Right? Let us see how to detect conditions A less than B. What are the two cases in which A is less than B? I have matching characters for A and B, but A ran out of characters. So, in this case, hell has only 4 characters and hello has 5 valid characters. I ran out of characters in A to compare with B. In that case, A is less than B. Or I do not run out of characters, but I am still in the middle of checking characters, but I see that some character in the middle is actually less than some character at the end. In this case also, we have A is less than B. So, these are the two conditions or examples for which A is less than B. And for everything else, we already considered A equals B, and I showed you when A is less than B. In all the other cases, A is supposed to be greater than B. So, this program that you see on the left side is supposed to take care of printing whether A equals B or A less than B or A greater than B based on these checks. So, let us see what this loop here is supposed to be doing. So, k is initialized to 0. We are starting with the 0th character of both A and B, and if both the characters of A and B match, and if I have not exhausted A and I have not exhausted B, then I can go and look for one more character, right. So, if I keep doing this, k will keep incrementing. So, if I start with, let us say hello and hell, k is supposed to point to the 0th character of both. So let's say this is my A and this is my B. So k initially starts with pointing to h. These both are same. I increment k. So k now so A of k is E and B of k is E. These two are same. Then I increment k. Now A of 2 is L and B of 2 is L. So as long as things are same, I have to keep moving right, and I will stop when either the condition that the characters are same is violated, or I ran out of characters in either A or B. So that is what these three conditions are doing. So now let us go and see. There are three ways in which you could have come out of this loop. Either you violate this condition, or you violate this condition, or you violate this condition. You could have come out because of violation of any of these. If A of k equals B of k for all the characters that you saw so far, then at some point, right, your n1 you would have hit n1 the end of A, and you would have hit n2 which is the end of B. So if n1 is actually equal to n2, and if k equals n1, which means you are looking for equality in A and B, then A and B are equal. So that is the example we have on the right side. Hello and A equals hello and B equals hello are actually the same. Else you ran out of characters in A, but the first set of characters, n1 characters in A and B are the same, but you ran out of characters in A, there are more characters in B to process, which means you have a word which is shorter than the other word. And so for example, hell is shorter than hello, and hell is a prefix of hello. In this case, A is less than B. If you ran out of characters in B, and if you still have characters in A, and if the first n2 positions matched, then you print A is greater than B. So we have taken care of three cases where we hit in some sense \0. So in this case we hit \0 on both of them at the same time. In this case we hit only on A of 0. In this case we have hit only on B of 0. None of these need to be true. For example, in bell and bull, I do not have to go to the end of the array to see that bell is less than bull. As soon as I see the 1th location, I see that E is less than U, therefore A is less than B. So that is what you are doing here. I did not run out of characters in either A or B. However, so there are still more characters to process in A and B, but however I found something lexicographically different. So A of k is less than B of k means A is less than B, in this case bell is less than bull. Or I started looking at H in both of these, I see that in the next location U and E, U is actually greater than E. So hull should come after hello, and therefore A is greater than B. So this is a way in which you can write a program for string comparison. Right. So we looked at 3 programs, one to find out the length of the string, one to concatenate, and one to copy. And finally we now looked at comparing 2 strings. So one thing that I did not show you is for concatenation, I did not show you how to write the program. So we can keep writing all these things every time, but it is a laborious thing. So for integers and floating point and so on, we had plus and minus and so on, which are basic operations. However, for strings it may be useful to have some of these things given by the programming language. Unfortunately C does not give that, but C gives it to you as a library. So these are all built-in string functions. If you do #include string.h, it has several built-in functions. So for example, you have a function called strlen. If you pass a character array to it, it will find out the length of the string excluding the length of the null character and return an integer. So strlen is a function which takes a character as a parameter, character array as a parameter. So it takes pointer to a character array and returns the length of the string. So you will see the notation and meaning of this in a subsequent video on functions. So you can treat these as inputs that is given, and this is the output. So the input is of type string and the output is of type integer. strlen is the name of the function. It takes a character array as a, or pointer to a character array as an input. So it has a program like what we saw for the length inside, which actually goes and looks at every single character and finds out \0, it reports the length and returns an integer. There is a function called strcpy. So, you take two parameters, character star destination and character star source. So, if you give strcpy of a comma b, it will copy contents of b into a. So, clearly destination must have a size which is at least as large as the size of source. Finally, there is another function called strcat. So, again as before we have destination and source. So, it will take source and concatenate it to destination. So, destination must have space at least as big as the original string that you had plus the new string that you are concatenating. So, these are things available from as built-in functions from C itself, and we can write it on our own, but we are prone to making mistakes. Instead, we use libraries given by C to do this. So, these are three basic things that you may want to use. So, there is another function called strcmp which can also come in handy. Strcmp takes two parameters as inputs which are both pointed to arrays and it returns an integer. So, we wrote a program which printed things on the screen as a less than b, a equal to b and a greater than b. Instead, it returns an integer. So, if both S1 and S2 are equal strings, which means if I gave hello and hello as S1 and S2, right, then both strings are equal, you will get 0 as the result. Instead of printing on the screen, it gives you an integer. You can go and look at the integer value and decide whether they are equal or not. You get 1 if the first string is lexicographically greater than the second string, which means in the dictionary, if the word pointed to by S1 will come later than S2, then you will get 1. You will get -1 as the return from strcmp if S1 will be in the dictionary order before S2. So, you get 3 values 0, 1 and -1 depending on whether a equals b and whether a greater than b or whether a is less than b. There is also another function called strncmp. What it does is, instead of comparing all the characters including \0, it will compare only the first n characters of two strings. So, if I have string S1, let us say this is of size 10 and let us say S2 is an array of size 15, and if I specify size as 4, strncmp will compare only the first 4 characters. It will not go till the end of S1 or S2, it will go only till the first 4 characters, and it will give you a comparison of the first 4 characters of A and B. It will still return 0, 1 and -1 by comparing only the first n characters. So, this brings me to the conclusion of strings. This is something that can come in quite handy for you. So, later you will see programming exercises which are actually on strings. So, I suggest that instead of writing things on your own, you go and use the functions that are given in the string library. All you have to do is do #include string.h, and just like printf, scanf and so on, you call functions by passing appropriate parameters. So, how to pass parameters and so on will probably become clear once you go through the video for functions. So, thank you very much and see you in the next lecture.